In Cinnamon, founder of Apex Space, founder and CEO. Well, welcome to We the Builders.
Thank you so much. It's great to be here.
I've been looking forward to this because one of our mutual friends was actually going to make the introduction, but this worked out because we were here. And
Which mutual friend?
Chauncey.
Oh, Chauncey's amazing.
She's
not just friend, investor, supporter, mentor. She's great. She's great.
Yeah, she's awesome. So we can start off. We were talking about a whole lot of other interesting stuff we can maybe get to, but I'd love for you to maybe explain to any of the newer audience what was the thesis behind starting Apex Space, and what were the other. I always like this question. What were the other career options at the time? What could have been an alternative reality you could have been living in?
People don't often ask that. That is a great question, and I will say, like, starting a space company today, where like defense and space is really sexy and everyone wants to go do it, like it may be like, oh, of course it's a space company. When I started working on the idea for Apex with my co-founder Max, space was something that was like a bet that like people were not making, right? We just came out of the ZERB era. It was like, why would you go do something so capital intensive?
The only right thing to do was start a crypto company.
It was crypto.
Yeah.
And I actually looked into doing a crypto company at the time. I did. I'll give you the whole story. But like, space at the time was like a very irrational bet because it was like, that's super expensive. Where's the space industry going and all of that? But there's a real reason that I decided to take the plunge, right? And space is hard. It's hard tech because it is not for the faint of heart, let me tell you. But to give you the whole story, I actually come from more of a software background. So I started an artificial intelligence and computer vision company started working in 2014, right? So well over a decade ago, before AI was cool. Kind of, missed the timing a little bit, but that's okay. And we were building these AI models for different national security applications. We ended up raising some venture money for that. And long story short, sold the company to Palantir.
I would love to ask some questions about that company. Was the customer primarily the government, or did it have a commercial application as well?
So it did. So at the time,
what was the problem?
Yeah, so
solving?
Effectively, I had worked in a research lab during my undergrad where we were taking a tremendous amount of kind of visual information and trying to understand how humans process it. So to give you some examples, right? That could be everything from in a medical environment, it could be a radiologist looking at x-rays and saying, is there cancer, is there not? In more of the environment where I ended up starting this company, it might be a TSA official at an airport looking through hundreds of scans of bags saying, is there a gun? Is there a knife? Is there something dangerous in there? It could be a drone operator looking at drone footage to say, okay, is this just like random fields or is there a tank or something bad there? And a little bit of it was satellite imagery where we were looking at all these swarms of satellite imagery and there were humans looking at it saying, all right, I need to look for anything that changed. And essentially the thesis of the company was for anything that was really, call it like defense related, where you have a tremendous amount of data and humans are analyzing all that data, could we build computer vision systems to look at it? And where we saw the most traction in the very beginning was actually around physical security at event venues or airports. And the reason was at the time, unfortunately, it still is the case, but especially back then, there were these mass shootings going on all the time. Absolutely terrible. And one of the concepts was, how do we apply AI and computer vision to help prevent these tragedies from occurring? How do we automatically detect when a weapon is entering some area or somebody's carrying in some sort of threat? So we decided to build a company around that. And we did. The tagline was AI for a threat-free world. And we actually built systems that worked really well. We deployed it at airports throughout the US, internationally. We helped secure the Abu Dhabi F1 race, did office buildings, federal office buildings. And we actually grew this thing. It turned out, though, that when this little thing called COVID hits and all of the venues that you're securing no longer have anybody going through them, business gets a little rough.
Yep.
And at the time, we had been talking about doing some work with Palantir around a few different applications. And they said, well, this has been a good partnership. What if we buy you? And long story short, we ended up joining forces with Palantir.
Yeah, I'll tell you a funny story. It didn't work out in a different way, but I went to college for electrical engineering. I was a horrible engineer. My team for their final year project, I didn't contribute to that project, but the team's project was exactly this.
Really?
It was analyzing footage from security cameras real time and use computer vision to detect weapons, etc.
I love it.
Yeah, and I didn't end up pursuing it because
It's a hard market to sell into.
It's a hard market
because you're selling it's almost like you're saying, hey, we're selling you security. This thing may happen. Like people will go buy a Band-Aid when they get cut.
Yeah.
But like people, it's hard to sell vitamins before, right? It's like, oh, if something terrible happens, they'll go buy something to like fix it. But it's hard to sell preventative measures like that.
Yeah, that's interesting that you came out of your undergrad with a similar thesis.
Exactly. You were smart enough to maybe not pursue it, and then I went in and slogged away. And,
but hey, you got Palantir stock out of it. That would have been worth
before they went public too. So it was worked out well.
Well, hopefully you didn't sell early.
We still have some. Let's put it that way. Sore subject. So thanks for rubbing it in.
So now you end up at Palantir, which interestingly, I've maybe had 2 or 3 ex-Palantir alum on the podcast, but there are a lot of former Palantir employees who go on to become entrepreneurs and successful entrepreneurs at that. I know you were there during the COVID era, which you mentioned, but why do you think that happens? And what are some of your biggest lessons from working at Palantir?
So Palantir is a truly amazing company, an amazing environment. Even during COVID, joining completely remotely, really, there's something special. And I think there's a few elements of it, but to me, there were 2 main things that really stood out. First, Palantir completely nailed the product market fit. Seeing how the customers of Palantir used it on a daily basis was frankly like I was a small cog in a large machine of Palantir, and it inspired me every day. You'd get up and you'd see how it's genuinely helping solve problems and move the needle forward. And you're like, oh my God, like the product market fit is incredible here. The second thing was Palantir really believed in empowering its employees to make decisions and do what was right. It's kind of a joke that there's very few titles in the company because it's a very flat hierarchy. You go do what you want. And it was true. Like everybody was empowered to go talk to customers, to move the ball forward, to make those right decisions. And it created just this culture of, I think, almost breeding these entrepreneurs where everybody said, oh, well, it was up to me to go win this deal or up to me to go, support this customer. And it worked. And I think those 2 things combined where you surround people with this strong product market fit and they see how it resonates with this culture of like, control your own destiny, go help this customer out, leads to people saying, well, I want to go find the right product market fit and then go do it.
Well, we're going to tie that back to how did Apex happen, because you weren't in Palantir for long, so you clearly had some unique insight at the time.
I had the itch to go start a company.
Yeah, the itch to go start a company. So you at the time space wasn't the hot or sexy thing to do as well. There probably wasn't as much capital flowing into hard tech. So what is the insight you had at the time? And so tell us more about Apex.
It's funny. I said I had the itch to do a startup. The honest truth was the moment I sold my company to Palantir, I said, I want to go start another company. And then I slowed down and I said, I want to start another company, but when I do, I want to make sure I'm really going to nail the product market fit. I'm very methodical about what we're going to build, because it's funny. Some people say, oh, it's great to be a serial entrepreneur. Maybe it's contrarian. I think a serial entrepreneur means you failed multiple times, which it's okay to fail. There's nothing wrong with that. That's how you learn. But I was like, I want to start one more company and never start another company again. Right. The whole point is like the next company I start will be the last one I ever built. Like that's the goal. So I really wanted to pick the right idea. So while I had the itch to start a company, I wasn't like, I must go do it immediately. I wanted to find the right idea. So I'm at Palantir and I'm working on some programs that touch space. And what I started to notice was that around the time COVID was going full swing, the industry around space was going through a massive, massive change. So what I mean by that is the space industry has been around for decades, literally 70 plus years. And for most of that time, it's been the exact same. And what I mean by that is you would go spend a lot of money. You would go build a very expensive satellite that has a very exquisite purpose. Maybe it's taking photos of Earth. Maybe it's doing astronomy. Maybe it's communications. Maybe it's a direct TV satellite giving you, letting you watch TV, whatever it may be, very specific purpose. You would design that satellite because it was so hard to build. You'd say, let's make it really robust and have it last 20 years, 30 years, so decades. And then you'd say, now I got to launch it to space. It was really hard to get satellites to space because there weren't really reliable launch providers. The rocket might blow up. So it was this very slow, expensive, and high-risk activity. But what I noticed when I was at Palantir was that all started to change. And the change was really driven, I have to say, by SpaceX. SpaceX started to reliably fly their Falcon 9 rocket. So it went from something that was a high risk, oh, will it work, to it's just working. They started reusing the rocket. So they got the launch cadence going faster and faster. And all of a sudden you look at that and you're like, wait a minute, if launch is now reliable, if I could launch far more often, should I rethink how I make satellites? Should I still spend 10 years and billions of dollars to build the perfect satellite? And while I'm at Palantir, I started noticing this trend. And the trend was people take Planet, Skybox, Digital Globe. At the time, companies like Umbra or Hawkeye were really getting started. Yeah. They said, let's go ahead and instead of spending $1 billion on one satellite, let's spend $1 billion on 10 satellites or 100 satellites or maybe 1,000 satellites. And the result of that is it's much lower cost. You get a lot more deployed to orbit. And effectively out of that, you get higher resiliency, meaning if one gets cyber attacked or shot down, you still have 99 others. You get higher revisit rates because satellites are constantly orbiting Earth. So if you have more of them, you're over the same point at Earth more often. And the data coming off of them becomes a whole lot more useful. So I see this happening while I'm at Palantir and I'm like, wow, this is a pretty cool moment. The industry is changing. But I'm there and I'm talking to all these companies launching satellites. And they're all saying the same thing, which is they can buy launch, they can process the data, but no matter what, they're having trouble building the satellites fast enough. They want to build them faster because they have so much demand. And as an entrepreneur, my ears perk up and I'm like, wait a minute. When you have one person say, hey, I wish this happened. All right. When you have 5 people saying, I wish the same thing was fixed, immediately like, wait a minute, should I go fix that thing? And I started thinking about this. And, you know, at the time, keep in mind, we're now like a year or two into COVID. I had just seen people raise crazy amounts of money at minimal dilution. We had all this crazy VC inflation. And I said, I promised myself I wasn't just going to jump into some idea. I want to be methodical and find the right idea. So I say I have to quit my job at Palantir. I'm going to go join one of my early stage investors, this great firm called Village Global. And I'm going to go incubate this idea and explore others as well. So I quit Palantir and I said, let me go explore this idea of satellites and let me go be an EIR and see how that goes.
What was another idea that you almost did?
Great question. So space was always on my mind, but at the time, remember that little thing called crypto and NFTs and that whole world? I mean, it was crazy what was going on. I explored that. I looked at everything from insurance. I really tried to look at it from first principles and said, this satellite idea is interesting. Before I go jump in and say, I'm just doing this, I said, let me really run the gauntlet and try to figure out all the different ideas, everything that piques my interest, my curiosity. I will say I was a little scarred from AI because I'd already done that, but I was looking at crypto, fintech products all over the place. But I kept gravitating towards a satellite problem. And I started chatting with a buddy of mine, who's now my co-founder, Max, brilliant guy. He spent his career scaling production at SpaceX. And we really honed in on the problem that the satellite was something that was almost being re-engineered every time. And it needed to almost be treated like a true product where you design it once and you go produce many, almost like an automobile, right? You go to the car dealership to buy a Ford F-150. You don't go there and you're like, design me a new car. You're like, I want that one that's on the lot. And we realized that that was the problem we had to go solve.
So was it more like a F1 team where the car is being re-engineered for every launch?
Yeah, I mean, the way to think about it is, if you wanted to go buy an automobile, a car, before the Ford Model T, it was somebody was like hand making you this car. It was custom made. It was uniquely designed. Versus after the Model T, it was, I need a car. It's like, well, here's 50 on the lot. Which one do you want? Go drive away in it. And the speed at which you could get it was really the core differentiator. And that's how we saw it as well. The speed at which our customers need these satellites is really the key.
Was that the bottleneck for other satellite manufacturers at the time?
Yeah.
So
everyone who was procuring satellites who was buying like what we sell today, the satellite platform, the big bottleneck was they were re-engineering them every time, and it was so slow and so expensive and riddled with problems. It really felt like it was like cars before the Model T.
So what is the opportunity in space? There are all these different orbits. There's VLEO, LEO, GEO. Like, can you like, explain what is the opportunity? What are the different use cases for each?
Yeah.
Where do your satellites primarily operate, and what do you mean by platform?
Yes. All right. So let me start with the platform one, because that explains kind of where our business lies. So as I mentioned, people wanted a lot more satellites, and a satellite is really comprised of two parts. One part is the payload. That payload may be a camera, a communications dish, something like that, right? It's taking pictures. It's maybe a scientific instrument. Now, if you just stick a camera up in space, it's not going to do much, right? Because it needs to point in a certain direction. It needs power. It needs to send the imagery back down to Earth. It needs to be able to move around. So the things that enable all of those features are what's called the satellite platform, which is also known in the industry as a satellite bus. So the satellite platform is the solar panels, the metal structure. It provides the radios, power, thermal dissipation, everything you need for the payload to function. So platform plus payload, functioning satellite. We do not make the payloads. We don't try to go make the payloads. We're not going to go make the payloads. We focus only on the platform. We're a platform company, and we build these platforms at a volume and pace that frankly has never really been done before.
Interesting. So do you partner with other payload providers for this?
We do. So we sell to them.
Okay.
That is who that is our customer. So if you look at pretty much every single major defense prime out on the market, nearly every single one of those is a customer of Apex.
Oh,
we publicly announced, for example, Anduril is a customer of Apex. We're I can tell you today, the breaking news here is Northrop Grumman has actually now become a very strong partner of Apex for space-based interceptors. So we're very excited to partner with them and support that mission set. There's just so many of these applications that require these high volume of satellites.
Is it part of the Golden Dome program?
That is part of Golden Dome.
What is the Golden Dome program for anyone who doesn't know?
Yes. So the idea of Golden Dome is to really create this protective shield to prevent missile attacks from occurring. And if you think about it, if you look at what is happening, for example, right now in Iran, missiles, or look at what's happening in Ukraine, missiles are really probably the greatest threat. And if you look at our peer adversaries, you look at North Korea or Iran, like they have missiles, right? Their ability to target the US, who knows if they can reach us. You look at our peers, China and Russia, they could definitely reach us. And that is a very scary proposition. So the key thing should be, and we already do a great job doing this in the US, is how do we prevent missiles from, God forbid, there's a terrible situation, from hitting the US? And the reality is today, the way that we take down a missile is a missile is fired. When a missile is fired, it actually goes up into space, comes back down, and then hits wherever its target is. The way we intercept missiles today is a missile is fired from the ground. We fire an interceptor from the ground, and they actually collide, usually in space. So you're basically firing a bullet after a bullet and having them collide, and both have to get all the way up to space. Or the idea of Golden Dome, and specifically space-based interceptors within Golden Dome, was if you're firing a missile and it's already going up into space, why don't you just have a satellite that is passing by, pop, just
neutralize it in space.
It's already right next to it.
Yeah.
So that is something that, it was in an executive order that came out a bit over a year ago. And when you read that, it's kind of this like obvious moment where you're like, wait a minute, like, yes, we should go do that. And the reason it hasn't been done before is actually the same reason that Apex now exists, which is nobody was building these systems at the scale that are required.
Right.
So we feel very fortunate to now be partnered with Northrop to work on this together, because that scale in manufacturing is going to be the key unlock that enables Golden Dome to actually succeed.
Interesting. How much room is up there in space?
There's a lot. So, okay, I'll give you an example. We're sitting right here, right now, at the beautiful Reagan Library. To get up here, you probably took the 101 freeway, right? The 101 freeway connects LA to San Francisco, runs all the way up, goes further up north, south, etc. Like massive freeway. There are more people that are currently driving on that freeway between here and Los Angeles right now, you freeze time and you count the number of cars between here and LA, right? Just like look at that number. I guarantee you there are more cars on the road right now than there are satellites in space. And there's a lot more space up in space. You're not dealing with one narrow stretch of road.
Right.
You're dealing with the surface area of Earth, but then you're going out hundreds of kilometers. So you have this massive, and you also are not talking everyone's at the same altitude. You mentioned other orbits. Some are higher, some are lower. There's so much room up there. It's not good if things collide, because when they collide, they create debris. The debris hits each other. It could create, it's called Kessler syndrome. We want to avoid that, but it's very avoidable. So when people are like, there's too many satellites, like, that's not true.
Not even close.
But we do have to manage it wisely. We have to be good stewards. Like, for example, at Apex, we're big believers in all the satellites that we sell. We make sure they're able to deorbit in under the required amount of time. So there's certain rules. They used to say within 25 years of non-operation, it must be deorbit. Then it's 5 years. We try to ensure every satellite we sell for a customer will deorbit even sooner than that after its useful life. Let's get out of the way. Let's not create any junk. That being said, there's a lot of room up there. We're going to be okay.
How do you deorbit a satellite?
So what you actually do is you have it re-enter Earth's atmosphere. And as it enters Earth's atmosphere, it burns up. And what you do is before you launch a satellite, you actually run a full report and you prove that it's going to fully disintegrate upon re-entry. And the odds of it, anything, getting through the atmosphere and hitting Earth are so infinitesimally small, it's completely safe.
I want to get back to these different layers in space and what are the use cases?
Yeah, so it's a great question. The way to think about it is there's different altitudes that you could fly your satellite at. You could fly it in very, very close to Earth, which is known as very low Earth orbit. That might be 100 kilometers, 200 kilometers up. You could fly it in a traditional low Earth orbit. That's maybe 400 to 1,000 kilometers up. You could fly it in medium Earth orbit. That's maybe 1,000 to 30,000 kilometers, or geostationary orbit. That's 30,000 kilometers. And if you think about it, okay, different altitudes, what's the difference? The closer you are to Earth, right? Let's say you're taking photos of Earth, the higher resolution those photos could be. The further away you are from Earth, the more of Earth you could see at a given point in time. So if you want to basically be able to see all of Earth from a single satellite, you need to be really far away to have a lens wide enough to capture all that. But if you're only 100 kilometers up, you're only going to maybe see like, a state or a city at a given time, depending on kind of the lens that you're using. So it really depends on the application. So to give you an example, if you're doing something like Earth observation, we design our small vehicle or small product line to be a good fit for that. You probably want to be in low Earth orbit, closer to the Earth, easier to take photos. If you're doing something like missile tracking, you probably want a combination of different orbits, but you almost certainly want most of your satellites in low Earth orbit, but a little bit higher up, maybe, 1,000, 1,200 kilometers, where you're further away so you could see more of Earth at a given time. So you're looking for that heat signature. If you're doing something like communications, depends what kind of communications. If you're doing something where you want to have very strategic comms to blanket an entire, call it state. There's this amazing company called Astronis, for example. They launched satellites all the way up to Geo, and with a single satellite, they could cover, for example, all of Alaska. Super cool. But the problem with that is the data from Alaska has to travel 30,000 kilometers, so there might be a little bit of a lag or delay. Or if you're flying in medium Earth orbit, maybe there's a half-second delay, and that creates a worse experience. Versus if you're in low Earth orbit, like Starlink, you're only 400 or 500 kilometers away. You don't even notice that lag. So every orbit has different trade-offs, different pros and cons. There's no, this orbit's better than that orbit. But I will say, if you're really far away, you don't need a lot of satellites because you could see everything. If you're closer to Earth, like in low Earth orbit, you need a lot of satellites. And for Apex, where we specialize, is any orbit where you need a lot of the same satellite platform over and over again. So we're not a fit for everything, right? But if you need a lot of satellites, right, and a lot of the newer systems need a lot of satellites, space-based interceptor is a great example. That's where we come in.
So how you're designing the platform is customer comes in, you're not really geo-specific, or you're more application specific. Correct. Which is, you're
doing missile tracking. Right. Here's our platform for you. You're doing space-based interceptors. Pick between these two.
If you need hundreds or thousands of satellites, we have figured out a system to do that. So let us help you do that.
Correct. If you need just one, though, we'll refer you to someone else.
Right. Right. That's very interesting. So you mentioned Astranis or an Umbra Space as well.
Yes.
So is
Both
Apex
great companies.
more of a partner to those companies, or is it
those
more
are
collaborative?
great examples of companies where, you know, we go after very different markets, right?
Right.
Space, as I mentioned, is physically a big space. There's a lot of room for a lot of satellites.
Yeah.
It's also a massive market.
Right.
If you look at it, Space Force's budget, we'll see how the full, you know, reconciliation, all of that goes, but that budget is going to nearly double. The number of satellites that are launching is exponentially increasing every year. For certain applications, like for example, Astranis for commercial applications, providing internet to underserved areas, amazing. Umbra for
primarily defense,
synthetic aperture radar, great. For applications where the government is buying systems, like we mostly sell to US government and allied nations and critical commercial companies. If they're buying high volumes of systems, that's where we uniquely make sense. So it really depends. We are a company designed for that high volume manufacture.
You mentioned on one of the podcasts, I think it was Joe Lonsdale, you mentioned that China has this goal of producing 10,000 plus satellites or something like that.
More than the goal. Like they're on track to do it. Like
they're on track. By when?
To be very clear, they've announced, I think the date was like end of the decade, 2030 or so.
Oh, wow. Okay.
So just a couple years, 3-4 years away. That's very soon in the space age. We are in a space race right now. And if you look at any recent like volatile activity in the world, Venezuela, Iran, it's happening in Ukraine, I promise you that more of that war is happening in space than anybody realizes. Space, whether it be taking images and helping our soldiers understand what's safe or not, strategic communications, all of that is happening from space. And the thing is, our adversaries know that. So they know that taking down our satellites, us taking that, like it is becoming a very scary world. And it's really a battle of who can get more systems up to space faster to win. And that is the area we compete in. Highly specialized satellites like what Umbra or Astranis or others are doing, those are great. They're going to go do well there. Different market. For us, it's a volume game. When you need constellations, space-based interceptors, certain missile tracking systems, certain Earth observation, others like that. That is uniquely equipped for Apex, where we come in and we can build those constellations incredibly rapidly and finally be in a position to win the space race that we are truly in the middle of right now.
At volume, I would imagine you're also able to reduce the cost.
Yes.
Right.
So the way that we think about this is we want to design systems that are affordable, that allow the constellations to work. Our goal is not to be the cheap provider on the market with systems that don't work. It's, you know, again, Ford is a great analogy here. Quality products. If you want a cheaper one, you could go do that. But no, you want the right middle ground. It's affordable, quality, good system. Like that is exactly where we fit into the market. To give you a sense of just like how dire the space race that we're in right now is, China has now launched, if you look at it last year, according to public data, they have launched more government satellites than the US government has. They're winning. We, in our facility in Los Angeles, are capable of building over 200 satellites per year. That is more than the number of satellites that the US government launched in 2024.
Oh, wow. Well,
so like we are already at the point where we can help massively increase our ability to win this space race.
We'll end with this because I know we've had limited time today, and hopefully we'll do a more long form for a standard form at some point. But why is it important for more satellites to be up there? What does that enable?
So one, the capability of each of these systems gets greater and greater with more that are up there. Space-based interceptor is a really great example of that. If you have one space-based interceptor up there and one missile is fired, you're good. But what if 2 missiles are fired? What if 100 missiles are fired? 1,000? You need all that capability. Missile tracking, same thing. Earth observation. If you have one satellite up there, let's say that satellite covers the same area every orbit or once a day. Let's just make it easy. Once a day. If you have 100 satellites up there, 100 times a day, you're getting new data points. Data is king. I mean, we're in the middle of this AI world right now. The more data, the more quality, the more revisit rate, all of that, that is the key enabler to actually winning and having more capability, more use of this data. This is exactly what I get to play with at Palantir. And like, I can just promise you, the more that are up there, the safer the world is, the more innovation is going to move forward at a faster pace, the more scientific research we do. It's a win for the entire world.
Well, Ian, thanks for coming on the show. Hopefully we'll get to chat more soon. And I'm looking forward to what Apex does with Northrop and some of the other projects you're working on.
Thank you so much. It's great being here.